All right, let's dive right in. We're going to talk about one of the absolute powerhouses of the modern web, the NGINX proxy module. This thing, it's the secret sauce behind the biggest, fastest websites out there. So let's get into it. So, you ever wonder how the biggest websites on the planet handle millions of users at once without just crashing? You know, like during a huge product launch or when something goes viral. Well, the answer isn't just throwing more servers at the problem. It's about being smarter with traffic. And that's exactly what we're going to break down today.
Okay, so the magic behind all this, it's a concept called a reverse proxy. And honestly, the best way to picture it is like a super smart, incredibly efficient receptionist for your web servers. It stands at the front door, takes all the incoming requests, and intelligently sends them to the right backend service. And, maybe most importantly, it protects those backend servers from having to deal directly with the wild west of the internet.
So let's actually build one, piece by piece. We're going to start with Chapter 1, passing the request. This is the absolute basics, the most fundamental job a proxy has to do.
The entire journey starts with just one single directive: proxy pass. Seriously, this one line is the beating heart of the whole thing. It's you telling NGINX, hey, see that request? Yeah, that one. I want you to pass it along to this server over here. It is, quite literally, what makes a proxy a proxy.
So here's how that journey looks, step by step. First, your browser, the client, sends a request to NGINX. NGINX sees it, checks its rules, and uses that proxy pass command to forward it right along. Then, the backend server does its thing, processes the request, and sends the response back through NGINX to the client. Super simple, right? It's a clean handoff.
But hold on, there's a really important little detail here. Your backend server needs to know who the original user is. Without a little help, it just sees the request coming from NGINX, not from, say, yourcoolwebsite.com. That's where proxy set header host $host comes in. It makes sure that crucial piece of information, the original domain, isn't lost. Without it, your application would be totally confused. It wouldn't know which site to show or how to build the right links. It's a tiny line that makes a massive difference.
Okay, awesome. We're passing requests. The proxy works. But, just working isn't what we're aiming for. We want this thing to be fast, blazing fast. So let's get into Chapter 2, supercharging with caching.
So the connection is solid, but what happens if your backend server is kind of slow? I mean, this is a super common problem, right? The backend has to talk to a database, do some heavy lifting, and all that takes time. If every single person has to wait for that, your site is going to feel like it's crawling through mud. So how do we fix this?
Well, the first tool in our belt is something called buffering. And the best part, it's usually on by default. What it does is pretty clever. NGINX will grab the entire response from the backend as fast as it can, hold on to it, and then slowly feed it to the client, who might be on a slower connection. This frees up your backend worker immediately. It's like, okay, I got this. You go handle the next person in line. Super efficient.
But the real game changer is caching. Just look at the difference here. Without a cache, every single request has to go all the way to your backend server. But with a cache, NGINX can just serve repeat requests right from its own memory. The client asks for something, NGINX says, hey, I've seen this before, here you go. And the backend server is never even bothered. Think about it for stuff like images or articles. This isn't just an optimization, it's how you survive going viral.
So how do we set this up? It's basically a three-part combo. The first part of our caching trio is proxy cache path. This is where you set up the storage space. You're basically telling NGINX, okay, I want you to create a cache right here on the disk, and you can use this much space. You're building the shelf before you put anything on it.
Okay, step 2 of the trio, proxy cache. Now that we've defined where the cache lives, this directive actually turns it on. You point it to the cache path you just created, give it a name, and bam, you've just flipped the switch and enabled caching for this specific part of your website.
And for the final part of our trio, we need some rules, right? We can't just keep old stuff in the cache forever. That's what proxy cache valid is for. It tells NGINX how long to consider a cached item fresh. So, for example, we can say any successful 200 response is good for 10 minutes. After 10 minutes, NGINX knows it needs to go ask the backend for a new version. This gives you total control over how fresh your content is.
All right, so now our proxy is not only working, it's fast. Like really fast. But what happens when something goes wrong? Because let's be real, things always go wrong. That brings us to Chapter 3, building a resilient proxy. This is all about the safety net.
Yeah, it's fast.
But what happens if the backend server just fails? This is the nightmare scenario, right? A server crashes, a bad bit of code gets pushed, the network hiccups. If your backend goes down, your whole site goes down. Well, unless you've planned for it.
Here's our first simple safety net: Proxy Connect Timeout. All this does is tell NGINX how long it should wait to connect to a backend server before it just gives up. The default is 60 seconds, which is a long time to wait. By setting this, you prevent a single broken server from tying up all your resources while NGINX just sits there, waiting and waiting.
And this is the ultimate safety net. It's called Proxy_Next Upstream, and it's basically an automatic retry button. It's what tells NGINX, hey, if you run into one of these specific problems with the first server, don't just fail. Automatically try the request again on the next server in line.
And you can get really specific about what counts as a problem. As you can see here, you can tell it to retry on a simple connection error or a timeout. But you can also get smarter and tell it to retry on specific HTTP error codes, like a 502 bad gateway or a 504 gateway timeout. This means you have incredibly fine-tuned control over what your proxy considers a failure.
So let's walk through what that looks like in real time. A request goes to backend server 1. Uh-oh, nothing's happening. The 60-second proxy connect timeout is reached. Instantly, Proxy Next Upstream kicks in and says, nope, try the next one. The request is immediately sent to backend server 2. And less than a second later, success. The user gets their page and they have absolutely no idea that anything ever went wrong. That is what resilience looks like.
Okay, let's wrap this up and look at the whole toolkit we've just put together.
If you think about it, we've really built this in 3 layers. Layer 1 was just the core forwarding, getting the request from A to B with proxy pass and proxy set header. Layer 2 was all about performance, supercharging it with buffering and caching. And finally, Layer 3 was the safety net, making it tough and resilient with timeouts and retries.
You know, it's funny, after all of this caching, resilience, failovers, all of it, the official documentation for this module says it simply allows passing requests to another server. That has to be one of the biggest understatements in tech, right? It hides so much power under such a simple description.
So, there you have it. You've seen the toolkit. You now know the fundamental building blocks for creating incredibly fast and reliable websites. So the only question left for you is, what bottleneck are you going to go eliminate first? Thanks for joining me.